What lies behind the veil of darkness, in the heart of the most mysterious object in the universe? Black holes. Their very name ignites the imagination and evokes primal fear. They are cosmic monsters, gravitational traps from which not even light can escape. But what if we could peer inside? What if a brave explorer dared to embark on the last journey of their life, a plunge into the abyss? Let us don an imaginary spacesuit and set off on a journey from which there is no return. To answer the question, what exactly would we see as we fall into a black hole? To begin with, let's understand our destination. A black hole isn't a hole in space in the usual sense. It's a region with an incredibly immense mass compressed into a tiny point. Imagine our sun compressed down to the size of a small city. The gravity of such an object would become so powerful that everything around it would start falling into it. And that's exactly what happens to massive stars at the end of their lives. When a star runs out of fuel, it collapses under its own weight, exploding as a supernova, and its core shrinks into an infinitely dense point, creating a black hole. So our ship is approaching its target. From a distance, the black hole looks like a perfect black sphere against the starry sky. It emits no light but absorbs it instead, so we only see the distortion of space around it. The stars behind it appear warped, their light bending around the massive object, creating an effect called gravitational lensing. It's as if you're looking at the world through warped and dark glass. That's the first thing that strikes you. The universe around the black hole looks wrong, broken. As we draw closer, we notice a bright, superheated disk of matter spinning around the black hole at breakneck speed. This is the accretion disk. It's composed of gas, dust, and the remnants of unfortunate stars that strayed too close. Frictional forces within this disk heat the material to millions of degrees, causing it to glow brighter than hundreds of galaxies. Paradoxically, the darkest place in the universe is surrounded by one of the most brilliant phenomena. Our journey takes us through this storm to the boundary beyond which reality ceases to obey the laws we know. This boundary is called the event horizon. It's not a physical wall, but rather a cosmic point of no return. Once you cross it, there will be no turning back. To escape a black hole from beyond the event horizon, you'd have to move faster than the speed of light. And the laws of physics as we know them forbid that. For an outside observer who remained at a safe distance, very strange things would begin to happen to you. Because of the extreme distortion of time at the event horizon, it would appear to them that you're slowing down. Your fall would become slower and slower, your image redder and redder, until you finally freeze at the very boundary, like a still frame, and vanish from sight forever. For them, your journey to the center would take an eternity. But for you, everything will be different. Nothing will change in your personal timeline. You will cross the event horizon without even realizing it. For you, there will be no wall, no flash of light, no special sign. You'll simply glide smoothly across this invisible boundary. And this is where the most interesting and most terrifying part truly begins. Your fate now depends on the size of the black hole. If you fall into a stellar mass black hole just a few times heavier than the sun, your demise will be swift and agonizing. Even before you reach the event horizon, tidal forces will tear you apart. This phenomenon has a terrifyingly accurate name: spaghettification. The essence is that the black hole's gravitational field is so uneven that the force acting on your feet will be orders of magnitude stronger than the force acting on your head. You'll start to stretch out like spaghetti. At first, you'll feel as if you're being pulled in different directions. Then this sensation will turn into unbearable pain, and your body will stretch into a long, thin strand of atoms before finally vanishing into the abyss. However, there's another scenario. If you've chosen a supermassive black hole for your journey, like the one at the center of our galaxy, Sagittarius A star, whose mass exceeds 4 million solar masses, your journey will be different. For such giants, the event horizon is much further from the center, and the gravitational field at its boundary is much more uniform. The tidal forces here aren't as strong. This means that you'll be able to cross the event horizon whole and unharmed. You'll find yourself inside the black hole. So what exactly will you see there? First of all, forget about total darkness. Once you cross the horizon, something incredible will happen. All the space around you will collapse. Now all paths lead in only one direction, towards the center, towards the singularity. You can no longer move through space the way you're used to. Space and time have switched places. Now, time is what pulls you towards the center, and space is what's left behind. If you try to turn around and look back at the universe you've left behind, you'll witness something utterly astonishing. Due to extreme time dilation, light from the entire future history of the universe will pour towards you. You'll see stars being born and dying in a single instant, galaxies colliding and merging, the entire universe living out its life until its ultimate heat death, all within the mere seconds you have left. You will bear witness to the entire future of creation, compressed into one dazzling moment. All this information, all this light, will fall into the black hole with you, and you will see it before the singularity engulfs you. And what lies ahead? Ahead lies absolute darkness. This is the path to the singularity. The singularity is a theoretical point at the center of a black hole, where density and gravity become infinite, and space and time, as we understand them, simply cease to exist. The very laws of physics that describe our world so well simply break down here. Neither Einstein's general theory of relativity nor quantum mechanics can describe what this is. This is the end of the path. This is the place where reality as we know it ends. When you get close to the singularity, spaghettification will inevitably catch up with you, even inside a supermassive black hole. Tidal forces will intensify exponentially, and eventually, you will still be ripped to atoms. But what happens to those atoms after that? What is the singularity? Here, science gives way to hypotheses. One of the most popular ideas to emerge from general relativity is that a singularity is simply a point of infinite density. All the mass of the black hole, every swallowed star, planet, and even you yourself, everything will be compressed into a volume smaller than an atomic nucleus. This is the end. The information about you, about the structure of your body, about your very thoughts, all of it will be erased. But there are also more exotic theories. For example, if a black hole rotates, as almost all objects in space do, its structure could be more complex. According to some models, the singularity in such a black hole is not a point, but a ring. Theoretically, one could fly through this ring. And what then? Some theoretical physicists, for instance, Roy Kerr, whose equations describe rotating black holes, suggest that such a singularity could be a passageway, a wormhole, or as it's also called, an Einstein-Rosen bridge. This is a portal to another part of our universe, or even into a completely different universe. Flying through the ring, you could find yourself in a place billions of light years from home, or in a world with different physical laws. However, there's one major problem. Even if such passages exist, they would most likely be incredibly unstable. Any attempt to fly through them would cause the wormhole to collapse. What's more, as you approach such a singularity, a wall of deadly radiation awaits you. So unfortunately, the idea of using black holes as intergalactic transport for now remains in the realm of science fiction. And there's one more great mystery connected to what happens inside. This is the information paradox. According to quantum mechanics, information cannot be destroyed. Information about any object is a complete description of its state, right down to every single particle. When something falls into a black hole, it seems that the information about that object vanishes forever. But where does it go? Renowned physicist Stephen Hawking suggested that black holes aren't entirely black. They very slowly evaporate, emitting what's known as Hawking radiation. This process takes an unimaginably long time. A black hole with the mass of our sun would take trillions of times longer to evaporate than the current age of the universe. But eventually, it will vanish. And what then becomes of the information it absorbed? Hawking initially believed it was destroyed, thus violating the laws of quantum mechanics. But he later changed his mind suggesting that the information is somehow preserved and encoded on the surface of the event horizon or within the radiation itself. This question still remains one of the hottest debates in theoretical physics. So what's the bottom line? Our journey into a black hole is a journey into the unknown, to the very limits of our understanding. We'll see space warp, time slow down, witness the entire future history of the universe in one single instant, and then we'll either be torn apart or we'll encounter the singularity, a riddle that modern science is still unable to unravel. This could be the end of everything, an infinitely dense point of oblivion. Or maybe it's the beginning of something new, a door to another universe. We don't know for sure. Black holes aren't just cosmic objects. They are laboratories where nature conducts its most extreme experiments with the fabric of reality. By studying them, we draw closer to understanding the most fundamental laws of the cosmos, to creating a unified theory that will merge gravity and the quantum world. And perhaps someday we will find the answers. But for now, it's the greatest mystery the cosmos has thrown our way.